Hello, this is Flight Instructor Online and welcome to the online PPL course for Explainer Flight Simulator. Let's get started with exercise 1A, Familiarization with the aeroplane. In this class we shall have a look at the characteristics of the aeroplane, the cockpit layout, systems, checklists, drills and controls. Although it is not necessary to complete the entire PPL theory course before we can start flying, we need to have a basic understanding of how the airplane and its systems work. Flight training can be done in almost any light airplane with 2 or more seats, and there are many of them to choose from. Initially, it doesn't really matter which one you choose. During this course we shall have a look at a few different types, but we'll start with one of the most common of all, the Piper Tomahawk 2. Specifically designed for flight training, almost 2,500 of them were built between 1977 and 1982. Many of flying clubs and flying schools still use the Tomahawk today because it's a very reliable and cheap to operate airplane. From an instructor point of view, I particularly like its flying characteristics. Where most trainers are built to be extra stable and make it very easy to fly, the Piper Tomahawk requires a proper pilot input, which makes it easier to see when you fly it the correct way, and also easier to see when you make a mistake. For example, in contrary to most other two-seat trainers, the Tomahawk is designed so that it does not recover from a spin without pilot input. But of course, when you give the proper input, it will recover right away. Note that the Tomahawk has a better safety record also than other airplanes of a similar type. The Tomahawk 2 variant has a few minor improvements over the number 1. Most notably the larger tires, which gives it a better propeller clearance over the ground, and a better heating and soundproofing in the cabin. Everything you need to know about this airplane is described in the POH, or Pilot Operating Handbook. It is a requirement for the pilot in command to study this manual before flight. But before you do that, let me show you some of the most relevant features. Let's look at the airframe. It is an all-metal, mostly aluminium, a fuselage with a monocoque construction, which means that all the strength and rigidity comes from the outer skin. The cabin has 2 doors, 2 seats with seat belts and a harness. There are dual controls, and compared to other two-seat trainers the cabin is spacious and there is an excellent view to the outside world. The wing is designed by NASA and specifically to give the Tomahawk its flying characteristics. On the leading edge, a pair of stall strips were installed in 1983 to make the airplane compliant with the new certification rules and improve its spin recovery characteristics. It has a low wing design, and as opposed to the high wing, this provides a much better visibility for the pilot, especially in turns. On the other hand, low wing airplanes are in principle less stable than those with a high wing, but to counter this problem, the wings of the Piper 38 are mounted in a shallow V shape. This is called a dihedral wing and increases the roll stability. The flight controls are conventional and they are connected through a cable system to the dual control yokes and rudder pedals in the cockpit. The flaps are on the inner trailing edge and they are also controlled mechanically with the Johnson bar between the pilot seats. The flaps are normally in the up position. They can be extended by pulling the Johnson bar between the pilots. In the flaps up position, that gives the least drag. Flaps 21, that's the first notch. This increases the lift and the drag. This is good for a short field takeoff, for example. Flaps 34, which is the down position, increases the drag, and this is good to improve the speed stability for the landing. The Tomahawk has a T-tail, and this design feature places the elevator outside the prop wash. Amongst other things, this reduces the vibration in the control yoke. The engine is a standard Lycoming 0235 air-cooled 4-cylinder piston engine which drives a 2-blade fixed pitch propeller. It delivers 112 horsepower at 2600 rpm. Like most aircraft engines, it has twin spark plugs in each cylinder, which are powered by a magneto system, which makes the engine completely independent from the onboard electrical system. There is a carburetor heat system to prevent ice forming on the throttle valve and a mixture control to lean the mixture when flying at higher altitudes. Let's have a look at the landing gear. It is a tricycle fixed landing gear which supports the airplane on the ground. The two main wheels have hydraulic disc brakes that can be operated independently by pushing the toes on the toe brakes. The nose wheel has an air oil type suspension and it is steerable via a torque link, which is connected also to the rudder pedals in the cockpit. Let's move to the cabin. In the cockpit we find 2 seats, 2 yokes, 2 pair of rudder pedals with toe brakes, a flap handle, 2 doors with lower and top hatches, a throttle, mixture, carb heat, magnetos and a few other items. The avionics can differ a bit for each airplane. The basic instruments that must always be available: airspeed, altitude, magnetic compass, RPM indicator and the other engine instruments, and fuel quantity gauges. Everything else is optional. Let's have a quick look at what we have in our Tomahawk. The primary flight instruments are called the basic 6. Those are the 6 instruments in the middle of the panel. On the left corner, the left top, is the airspeed indicator, or EASA. Top row in the middle is the attitude indicator, which is a suction-driven, gyroscopic instrument, and it presents an artificial horizon and is required for flying in reduced visibility. On the right is an altimeter. There is a subscale, which is either in hectopascals or in inches mercury, or a combination of both. If the subscale is set correctly to the QNH, or the local pressure, it indicates the altitude above mean sea level in feet. Going to the lower left corner, we see actually 2 instruments in one, the turn and slip indicator. The turn indicator is an electric powered gyroscope instrument and it shows us the rate of turn. The skid ball is just a ball in a glass tube filled with oil and shows us the turn coordination. The heading indicator in the middle is a suction-driven gyroscopic instrument, and if set correctly it indicates the direction or the heading of the airplane. And it's just a little bit easier to read than the magnetic compass on the top. The last one on the bottom right is the vertical speed indicator, which indicates if the airplane is climbing or descending in a scale of feet per minute. The other instruments on the main panel are for radio navigation and will be explained in a later exercise. Below the vertical speed indicator we see the RPM indicator, and on the right hand side some other engine instruments. The RPM is the rotational speed of the propeller and is a good indication of the engine power produced. There's on the right the exhaust temperature, which can give some information about the fuel and air mixture ratio, and the oil pressure and oil temperature gauges are a good indication of the health of the engine. Okay, let's have a better look at the electrical system. It is powered by an engine-driven alternator and a 12-volt battery. It feeds all the internal and external lights, the pitot heat, the stall warning system, the electrical starter motor, the electrical fuel pump, the radios and some of the flight instruments. Electrical switches can be found on the lower side of the main panel, on the left hand side, and the circuit breakers on the right hand side. The vacuum system is powered by an engine-driven vacuum pump. It supplies power to some of the gyroscopic instruments like the artificial horizon and the heading indicator. The system is independent from the electrical system to create redundancy. A suction indicator is located on the main instrument panel to show if the system is working. The pitot-static system feeds the airspeed indicator, the altimeter and the vertical speed indicator. On the bottom of the left wing you'll find the pitot probe, and on the aft fuselage you find the left and the right static ports. The pitot probe is heated to prevent blockage in case of icing or in heavy rain. Also on the left wing you'll find the stall warning system. The stall warning sensor is connected to a little metal tap on an electric switch, and if you approach the critical angle of attack, the metal tap will be lifted in the relative airflow. A micro switch will activate a buzzer in the cockpit to alert the pilot. The engine runs on standard Avgas 100 LL, which is a low lead aviation petrol, and it's stored in 2 wing-mounted tanks of 15 US gallons each. A fuel selector is located in the center of the control panel. The fuel system comes with 3 drain points. There's one drain point on the lowest point of each fuel tank, which should be drained every morning before the first flight of the day. And there is another drain in the fuel strainer, which should also be drained once a day before the first flight. So this was just a basic overview of all the technical systems on board the airplane, and a more detailed description can be found in section 7 of the POH. Checklists, drills and procedures. A procedure is a sequence of handlings that are common to a certain phase of flight. Some procedures are quite casual, like setting up the radios before flight. You can do them in any order, as long as they're all done. Other procedures require a strict order. As an example, when you park the airplane, the drill is parking brake set, 1000 RPM, landing light off, and you'll do this every time when you park the airplane. In most cases we operate the airplane completely from memory, but the error is human and we need a checklist to make sure that all critical items are set correctly. There are normal, abnormal and emergency checklists, procedures and drills. All emergency checklists are described in section 3 and all normal procedures in section 4 of the POH. Note that if you open the POH and you look in chapter 4 for the normal checklist, this is actually the normal procedures. Most operators have made their own abbreviated checklist for daily use. You can use mine if you wish. I'll put a link in the notes below. So that was the Piper Tomahawk in a nutshell. Why don't you take a little break, and when you are ready for some emergency drills, join me for exercise 1B. Thanks for watching.